1 mole of an ideal monoatomic gas undergoes an isochoric process from an initial temperature Ti equal to 100 Kelvin to a final temperature Tf equal to 300 Kelvin. Calculate the change in entropy of the gas during the entire process. If the temperature during the process is fixed, we can use this formula to find the entropy change, where the delta S is the entropy change and the Q is the heat transfer and the T is the temperature in Kelvin. But now these questions, the thermodynamic process involve the change of the temperature from 100 Kelvin to the 300 Kelvin. So we cannot use this formula. You have to use this one that involve the integrations to find out what is the entropy change of the process. In this isochoric process, the temperature changes from 100 Kelvin to 300 Kelvin. So when we calculate the entropy change of this process by using this integral form, we need to add the lower limit and the upper limits of the temperature. For the isochoric process, the heat absorbed by the gas can be calculated by using this formula, where the Q equal to NCV delta T. N is the number of mole, CV is the molar specific heat of the gas at constant volume, delta T is the change of the temperature. But in this integral, it involves the dq, which is an infinitesimal change of the heat transfer. So we have to change this into the NCV dt. That means the infinitesimal change of the heat is related to the infinitesimal change of the temperature. The N and the CV is a fixed value, so we will only integrate the T, temperature. Now we have the result of the integration is the ln T, where the lower limit is Ti and the upper limit is the Tf. Substitute the lower and upper limit, then we will have the change of the entropy is equal to NCV multiplied with ln T final minus ln T initial. The things in the bracket now can be simplified to ln T final over T initial. We start to substitute the value given in the questions, where the Ti is 100 Kelvin, T final is 300 Kelvin, N is the number of mole, it is 1 mole, and the CV for monoatomic gas is 3/2R. We take the R value, get the gas constant as 8.31. Now we have the delta S equal to 13.7 joule per Kelvin. This is the entropy change for the gas after the completion of the isochoric process.